Hello and welcome back. We are in chapter 2 of Sports Stats still. We've got comparing two proportions. And at the end of the last lesson that we talked about the idea of causation and how you end up with these confounding variables because you don't have enough information to be able to determine if indeed that one thing was really what caused the situation. So whether if that be home field advantage or whatnot. But today we're going to look at how can you design an experiment to then be able to actually determine what that exact cause is. So things that you're going to be able to do before the end of the lesson. Okay, you should be able to explain the difference between an experiment and an observational study. You should be able to define and determine the response variable and an explanatory variable. And you should be able to explain how to set up an experiment, including the treatment, and explain the importance of control and random assignment. So, do free throw distractions work? Okay, have you ever been watching a college basketball game or even a pro game? But college is really like the mecca of craziness for trying to affect people's free throws. Okay, so you have student sections that are just going nuts trying to distract the free throw shooter. Okay, so then this begs the question, do basketball players have a lower ability to make free throws in that hostile environment when all this craziness is going on? Okay, so if you've never seen this in action, I'm going to quick bring up a clip of one. I'm not going to show all of these, but we'll definitely we'll bring one of these up so that way you guys will have the opportunity to watch a little bit of this right here. So here we go. All right, so we're not going to watch this entire video, but I will I will post this in the link so that way you guys can take a look at the entire thing if you would like to. So let's get back to the PowerPoint for now, though. Okay, so we are going to look at, what these experiments would be. Okay, so we're going to go on to how do we do this? Okay, so the way that we'd have to test something like this, right? If the environment makes a difference, okay, in during this time, does that hostile environment change the person's ability to make free throws, right? Then that means that we have to create an experiment. So, right, we're going to set all these parameters to determine how this is going to happen. Okay, so the treatments are deliberately going to be imposed on individuals to measure their response. Okay, so let's talk about some of these key elements of the experiment, and then let's look at how we would set up the experiment to test if there really is a difference in environment when shooting free throws. Okay, so the treatment. Okay, what exactly is it? Well, it's what each individual in the experiment is assigned to do. So in this experiment, right, we were looking at the shooting percentage using two different treatments. The first one would be shooting free throws in a distraction-free environment. The second one would be shooting free throws in an environment that involved distractions, that hostile environment. Okay, the response variable measures the outcome of interest. Okay, so what would represent the response variable in this situation? So it would be whether or not that shot was made. Okay, so the response variable is the outcome. Was the shot made or was it missed? Okay, whereas the explanatory variable, that's what's deliberately changed to see if it causes a change in the response variable. Okay, so what would be the explanatory variable here in this situation? Okay, right? It would be the type of environment, right? Is it a distraction free environment, or is it an environment that involves distraction? So, how do we set up this experiment? Well, there's some things we have to look at, right? When we set this up, we want to make sure that we're being very careful. Okay, so first of all, let's think about it this way. If we're going to make this a 100-shot experiment, would it make sense to have one person shoot 50 shots in a distraction free environment and then turn around and shoot 50 more shots with distractions? Right? That's a big no, right? Because at the time, right, when you're done shooting 50 shots, you might be a little tired, right? So then your second set of shots, right, it's not really the same environment, right? Because the fact that you have that's another factor there, right? And the only factor we want to be different is to be, right, if it's the harsh environment or if it's the distraction free environment. Okay, so how do we have to avoid this? Okay, we're going to use one of your favorite words that by now I'm hoping is one of your favorite words, random, right? Or randomly. Okay, so we're going to randomly assign our treatments, okay, meaning that we need to use a chance process to assign the treatments to avoid any individual attempts, okay, so that no treatment is given an advantage. So one way that we could do that, right, is to go back to our note cards, right? And for those 100 shots, we need 100 note cards. Okay. And on those note cards, we would write a D on 50 of them for distraction. And we would write an N for no distraction on the other 50 cards. We'd shuffle those cards up, right, where we wouldn't know the order that they're in. And then one at a time, we would just flip them over. Okay. And whatever it said, distraction or no distraction, that would be the order in which the shots were taken. So it's the 100 cards for the 100 shots. Okay, this should ensure that one environment isn't given an advantage or disadvantage over the other. Okay, another important aspect of this experiment is making sure to control the environment. Okay, this means that all conditions have to be kept exactly the same for each trial except for the treatments being compared. Okay, so that means in this context, right, you want to make sure that the conditions the participant is shooting in, right, are the same for both shots except for the distraction. So, what are some of the things that we should keep the same? Not sure how many you came up with, but here's just a short list. Okay, we want to make sure that we're using the same basketball, that he's wearing the same shoes, okay, that the shooter's shooting at the same hoop in the same gym, right? So when you're inside, some of these things are a little bit easier to control, right? Because you're in the same gym, it stays the same. Whereas when you're outside, if you're kicking field goals, for instance, right, you can kick in the same direction. But if there's a breeze going on, the difference in the amount of breeze, or you get a wind gust as the kicker kicks, and that can have an effect on things. Okay, so this is nice because we're in a controlled environment of the gym. So by controlling all other conditions, then we're really only truly looking at that explanatory variable. Is that going to be the cause of the change in ability? So assuming that we get that convincing evidence, then we can say that this actually is the cause of the difference in ability. So in this case, right, if we find convincing evidence, then we would be able to say that the reason the reason is that shooting environment. However, right, if we don't control all their aspects, they shoot the hoops at different hoops or with a different ball, or whatever, right, then that would change, right? We might still be able to say that there is a change in ability, but we would go back to that causation issue and we would end up with confounding variables again. So we have to control each and every aspect of it. Okay, so let's think about this, right? We've been writing hypotheses for the last couple of assignments, right? So what would our hypotheses for this experiment look like? Okay, well, our H naught, right? That's has to be that the players have this, or the player or players have the same ability to make the free throw without distractions as they do with distractions, right? Because the null hypothesis always has to be that they have the same ability. Whereas the alternative hypothesis, right, that's what we're hoping to be true. That's what we're hoping to see, what we think will be true. And that is that basketball players have a greater ability to make free throws when shooting without distractions. Okay, so by setting them up this way, right, we should be dealing with positive test statistics, right? Because we're going to say, right, that the ability is greater without the distractions. So, okay, here are just some results from someone who took 100 attempts and the two conditions. Okay, if we were in class, we'd actually have someone shoot a bunch of times, but we're not in class, so we don't have that ability. Okay, so they took their 50 shots with no distractions, 50 shots with distractions. Okay, these were the totals. Okay, so we made 32 out of 50 shots when there were no distractions, made 20 out of 50 when there were distractions. So overall, shot 52 out of 100. So the results of the shooting environment in a graph form. Okay, here we have the segmented bar graph. Okay, right, made 40% of his shots with the distractions and made 64% of the shots when there were no distractions. Well, that was one individual time. So now it's simulation time, right? So we have to do, right, we want to use the technology. So just to kind of remind you of these things, okay, I've got this laid out again, just like I did on the last one. Okay, the link is there to get you to the page you want to go to, right? Then we have our context one success and attempts, our context two successes and attempts, right? It's without distraction and then with distraction. Then we're going to calculate the observed difference. Then we're going to enter in 100 times, add more trials for it. And then at the bottom, we're going to look, when is that difference 0.24, because that is the difference between, in percentage, it's 24% difference, making 20 out of 50 as it is making 32 out of 50. So if we come over and we bring this up and we put in our numbers, okay, 32 out of 50, 20 out of 50, right? We calculate our observed difference in proportion. And then we always want to simulate 100 more trials. It's just the easiest way to do it. Okay, we add that in, we come down and we want to count the number that is greater than or equal to that observed difference up above of 0.24. Click on here and count and look at this. There's one dot that is greater than or equal to the specified value, right? So we're 1 out of 100 or 1%. Okay. When I ran this, when I was creating this PowerPoint presentation, okay, this was the graph I got, right? But 1% and 0%, right, are actually going to have the same answer, right? So we're just going to look at these statistics that I have right here on the screen in front of you. Okay, so in this particular one, the p-value is 0. There are none. So what conclusion can we make when the p-value is 0? Well, remember, there are 3 parts to every conclusion. So we have the first part, because the p-value of 0 is less than the significance level of 0.05. Then we have the second part, we're going to reject the null hypothesis. And then we have the third part that says then there is convincing evidence to support the claim that this particular student has a greater ability to make free throws when shooting without distractions. Okay, so we got to make sure when you're stating your conclusions, you give all 3 parts. All right, so making conclusions from experience or from experiments, right? Up until now, everything that we've done, we were dealing with observational studies, right? We went out and find data that already existed and we observed what happened in those situations. Whereas this time, right, we're looking at creating our experiment ourselves, right? So before, when we had those observational studies, right, we couldn't impose any type of treatments. We could say that yes, there was a difference in ability, but we had that causation issue, right? We always had confounding variables where we couldn't say that this one thing was what caused it. But that's the cool part about creating the experiment, right? So with the experiments, because we controlled all those other things, including making sure that we randomly assigned, right, when each shot was going to be made, this allows us to do that actual cause and effect conclusion. Okay, so in this free throw experiment, everything stayed the same except the environment. So because of that, right, if we find that convincing evidence, then we can actually conclude that the only plausible explanation for the shooting percentage being higher was the environment without distractions, because it was the only thing that changed. Okay, so if this happens to be an observational study, right, we would say that it changed. We couldn't say why. Okay, but because we control all of it, right, that's when we can say that it's different. Okay, that indeed the one caused the other. So thank you so much for joining me for this. Hopefully, you learned a lot, and I can't wait until our next lesson. Hopefully, you guys are having a great day. You're making good choices, and enjoy.